Hello friends and welcome to my YouTube channel. I am going to design log periodic dipole antenna using CST MICROWAVE Studio, and then I will build actual antenna. But before that we will design this antenna in MATLAB. That is, we will use MATLAB to um, calculate all the parameters, values, length of elements, and other required parameters like alpha, sigma, then the total length of the structure, and so on. All these parameters will be calculated using the program developed in MATLAB. So here I have developed MATLAB program, and we will calculate parameters for a 45 megahertz to 1.5 gigahertz frequency range. So the diameter of all element will be same, that is 0.4 inch, which is near about 10.16 millimeter. The value of tau will define the design length of structure, frequency 45 megahertz, so wavelength will be very large, so we will use tau minimum, so this will give small structure, because if we change the value we can enter the value from 0.7 to 0.95, that is the limit of this design. So if we change the value of tau, the number of elements will be changed, length of structure will be changed, virtual apex length will be changed, and on all parameters will be changed. We will use 0.7, and this will give us the total number of element, that is 13. Okay, and the length of structure will be 8.5 feet. So if we change, let's see again, 45 megahertz 1500, diameter 0.4 inch, this tau value if we change 0.75. okay, so now the length, total number of elements are 16. So here is total number of elements, n is equal to 16 elements, and the length of structure is now increased to 11.3 feet. Okay, and so on. If we change value of tau to, let's say, 0.815 or 851, okay, so the total number of elements now are 16. okay, so length of structure is 22 feet. But the advantage of this structure will be the smooth transition of frequency from one element to another element. Okay, so let's say we will design 0.7, because we have to design for small structure 0.4, and the tau value is 0.7, and we will take a printout of this. So okay, so let's design in CST MICROWAVE Studio. Templates, project templates, from we can choose what we want to design. So we are going to design antenna, so we will make microwave and RF and optical application area. So here are some different fields that you can use to design. We are going to design antenna, so we will choose antenna. But before that we will make a different folder for this. So let's make a new folder, and we will say it as LPDA frequency is 45 to 1500 megahertz. Okay. Okay, so we have this, and we will make new project using this. Okay, so next, now we are going to design wire antenna, so we will choose wire antenna. Next, so this is given for large and thin wire antenna, this is for thick wire antenna, large and thin. Let's design using time domain, but as we are going to design in all dimensions in millimeters, so we will not change, so this will keep as it is. So design frequency is 45 and the maximum is 1.5 gigahertz. Okay, and now you can select which field you want to monitor. So E field, that is electric field, magnetic field or far field. This will give you radiation patterns. This will show the distribution of magnetic field in the structure. For electric field distribution in the structure, we will just monitor for far field, and the frequency will be 45, 700, 1500. Let's add another 100, then let's say 300. Okay, then 500, let's make it as 90. Okay, and then 900, 1300. Okay, 1100. Click next and give the name for the project template and click finish. Okay, so here new project is open, and let's close this. We don't need this, so we'll get large screen. Let's save this. We'll give same name. Okay, but in different folder. Okay, so this we have designed, we have made this folder, and now we'll save result also here. So click save. Okay, so let's change some settings. We don't need this bounding box. Okay, and now this is okay. Now start design using modeling plane. Okay, so here is brick. Using brick you can make a boom, so I am going to use a square boom and hollow. Okay, it depends on you, you can use solid or hollow. Press escape and give the name as boom, sorry, boom 1. Okay, the x minimum and y minimum. So x and y minimum and maximum will define size of your boom. Okay, so let's design using 1 inch. So this is 12 point, this will be 12.5, that is minus 12.5 mm and plus 12.5 mm. Also the y minimum will be minus 12.5 mm and plus 12.5 mm. So this z will be the length of boom. Okay, so the minimum length is 0 and the maximum will be, so my structure length is 8.56 feet. Okay, so let's convert this feet to millimeter. Okay, feet to millimeter. Okay, so the feet is 8.564020 by rounding off. Okay, and let's choose material aluminum. So you can use PEC and other these available material in library. Different materials are available. I am going to use aluminum, which is normal type material. Okay, click load and then preview how the structure will look like. So the boom is now designed at given parameter. So but it is solid. Okay, so we have to make it as hollow. So let's pick a point. We can use this, double click, then again change orientation, and we will select this peak also. So this peak. Okay, we have selected 2 points of the boom, and now in shape tool, okay, select this component boom 1 and convert shell solid or thickened sheet. Okay, so click outside and thickness we will keep is at 2 mm. Let's preview. Okay, so now this become hollow. Okay, as you can see, this is now hollow boom. Further, so number of elements are 13 and length of first element is, we will enter, but as all these elements are cylindrical shape, so let's pick cylinder and press escape. Okay, so we will give name as element ELE1, as orientation will be at x and -x. Okay, so we will select x. Now outer radius, as we are going to design 0.4 inch, that is 10.16, and inner radius, so we will keep thickness as 1 mm, so it is 9.16 mm. The total length is lambda by 4. selected this design. Now we have to make same identical opposite another structure of this LPDA. So before that we will make this as a one part. Okay, so here is boolean addition, we will make addition. Okay, now select the element, press enter, again select next element, press enter, and so on. Select 6th element, press enter, then 7th element, press enter, 8, 9, 10, 11 and 12. Okay, so this is the complete one structure. Now make a copy of this and paste here. So we have same two structure. Now select OK, so press enter. Now select structure second and we will transform it. Okay, so let's shift this above. So here is 25 plus the center to center spacing were different, but for feeder conductor it is 1.1, that is 11.45. Let's preview. Okay, apply, and we will rotate. So rotate it as for 180 degrees. This is 180 degree. Okay, so make it 180. Preview, and now this is our final antenna. This is the final structure of LPDA. Okay, press OK. Pick a point. Okay, this one and this one. Now we will add point on a face. Okay, so here is one and another is here. Okay, okay, so P1 and P2. So click on discrete port, don't change anything. Let's say apply and OK. So we have now added port. Okay, and we will now define the background and boundaries. Okay, so background in all direction, surrounding space in all direction. Okay, or you can change this also. Okay, so material type is normal, flat. Okay, change boundary condition. Add space. start. Okay. Okay, so this is now running and we don't know how many time this will take to complete the process, so let's wait for process to be completed. Okay, so here we have finished the simulation and let's check the result. So here we have one dimension results. Okay, so okay, this is port signal, then S parameter. So there is little variation in S parameter, and the most important is VSWR. So it must be less than 2. Is that power? Okay, so this is radiated power, accepted power, and the reflected power. So you can see that reflected power here. Okay, so let's see far field patterns, and here we go. For 45 megahertz we have this radiation pattern. Okay, so you can change show structure, transparent field, transparent structure, and so on. So different. Okay, let's say polar graph. Let's check it. Now this is